Hello friends, welcome to EC Academy. In this lecture, let us understand the problems on DFT. Now let us consider the first problem where they are asking us to compute the N-point DFT of the signal which is given by x of n is equal to delta of n. In exam they can ask you to find N-point DFT or 4-point DFT or 8-point DFT likewise. So in this problem they are asking us to find N-point DFT. To solve this problem, first let us write the formula for DFT that can be given as x of k is equal to summation of n is equal to 0 to n minus 1 x of n into e to the power of minus j 2 pi by n into kn. In place of x of n, let us substitute delta of n and we can write x of k is equal to summation of n is equal to 0 to n minus 1 delta of n e to the power of minus j 2 pi by n into kn. We know the delta function that can be written as delta of n will be equal to 1 for n is equal to 0 and delta of n will be equal to 0 for n not equal to 0. Using this analysis, we can write delta of 0 into e to the power of minus j 2 pi by n into k into 0. So what we have done, in place of n we have substituted the value 0. Now this term will be equal to 1 because e to the power of minus 0 it will be 1. We know delta of 0 is equal to 1 since n is equal to 0. So we will get the DFT of given signal as 1. Let us take the second problem where the signal x of n is given as delta of n minus n naught, where n naught is ranging between 0 and n. For this signal we need to find the DFT. First let us write the formula x of k is equal to summation of n is equal to 0 to n minus 1 x of n e to the power of minus j 2 pi by n into kn. In this formula let us substitute x of n as delta of n minus n naught. So we can write summation of n is equal to 0 to n minus 1 delta of n minus n naught into e to the power of minus j 2 pi by n into kn. Similar to first problem, in delta of n, when value of n became 0, this entire term become 1. Using the same analysis, we can write this term will become 1 when n minus n naught is equal to 0. So at that case we can say n is equal to n naught. So we can write delta of n minus n naught will be equal to 1 when n is equal to n naught and it will be equal to 0 when n is not equal to n naught. So only when n is equal to n naught this term will become 1. For other values this term will become 0. So we can write x of k is equal to, this term we can write 1 when n is equal to n naught. So it is 1 into e to the power of minus j 2 pi by n into k into n naught. So the DFT of the given signal x of k is equal to e to the power of minus j 2 pi by n into k n naught. Let us take the third problem where the signal is given as x of n is equal to a to the power of n. Here the value of n is ranging between 0 to n minus 1. Let us write the formula x of k is equal to summation of n is equal to 0 to n minus 1 x of n e to the power of minus j 2 pi by n into kn. Let us substitute the value of x of n as a to the power of n So in this formula we can write summation of n is equal to 0 to n minus 1 a to the power of n e to the power of minus j 2 pi by n into kn. So this we can write it as summation of n is equal to 0 to n minus 1. If we take power of n as common in these two terms, we can write a into e to the power of minus j 2 pi by n into k whole to the power of n. We have a formula which says summation of n1 to n2 a to the power of n can be written as a to the power of n1 minus a to the power of n2 plus 1 divided by 1 minus a for a value not equal to 1. Remember this formula. This is very helpful for solving many problems. Using this formula we can write the above expression as x of k is equal to a to the power of n1. n1 is 0. So a to the power of 0 it will be 1 minus a to the power of n2 plus 1. n2 is n minus 1. So it is n minus 1 plus 1. So plus 1 and minus 1 will cancel out. We will be left out with n. So we can write 1 minus a e to the power of minus j 2 pi by n into k whole to the power of n divided by 1 minus a is a into e to the power of minus j 2 pi by n into k. Here we can cancel out n. So we will be left out with a into e to the power of minus j 2 pi k. E to the power of minus j 2 pi k, we can write it as, we can write this term as cos 2 pi k minus j sin 2 pi k. If we put different values for k as k is equal to 0, 1, 2 and so on, the term sin 2 pi will become 0 and this term will become 1. So e to the power of minus j 2 pi k will be equal to 1 minus 0, that is equal to 1. So in place of this term we can replace it by 1 and we can write 1 minus a to the power of n, because this power will be with a also. That's why we can write it as a to the power of n divided by 1 minus a into e to the power of minus j 2 pi by n into k. So this is the DFT for the given signal a to the power of n. In the next lecture we will solve some more problems on DFT. Hope you understood this topic. Thank you.